Oh my goodness, welcome back. Gosh. You all right? Oh man. Take your time. Okay, everyone, if I could have your attention here, whether you're distracted or not, this is going to be a very important part because I'm going to provide you an analogy for today's lesson. That is regular future 8.5 future value of regular annuity. I'm going to provide you an analogy based on rolling a large snowball. Okay, this analogy, I'm going to take it and I'm going to change it later on at the end of the week. And so in hopes that it will help you read a question and understand which of two formulas you are going to use. Okay. I know some of you are like, what are you talking about? You will see. I want to give you that disclaimer if you ever decide to revisit this video. Future value of a regular annuity. The equation that you are going to be using, as you see on the sheet on the back, is going to be the final amount, or I'm going to say future value. Your final value is going to be some capital letter R, full bracket. You have this, you probably recognize this portion, and then NT. And then this is new. Since when do you subtract by a 1? Divided by R over N. Since when do you divide? So that is not something I expect you to know where it came from. It's actually based on I'm going to say a grade 11, grade 12 concept called discrete functions. It's basically a field of math where we look at patterns. I don't know how many people when they were younger, they were given like math patterns and you were told to figure it out. Like for example, here's a simple one. What pattern do you see here? And tell me what the next number is. Think. What's the pattern? Alex? Yeah, it's going up by 2, up by 2, up by 2, and then so you can write the next one as 13. Did you know you can actually write this as an equation saying whatever number I have added by 2, right? And there, of course, there's more to it, but here's another one. You ready for this one? All of a sudden, I gave you hard mode. Like, what's this pattern? Anyone recognize that pattern? I just went from like level 1 to like level 55, okay? So there's a lot in between. So give yourself like 30 seconds. Tell me what the next number is going to be and how you found that out. Just give it a second. Brendan?
The next number is going to be 4.
Yeah, how'd you know? Correct. Good naming. Yeah, what does that mean?
So you just add
to get the next number, you will add the previous 2. So 1 plus 1 is 2, 1 plus 2 is 3, 2 plus 3 is 5, 3 plus 5 is 8, so on and so forth. And that's a very famous pattern. When you think about an annuity, and you will see what I mean by a pattern, okay? You can take a pattern and we create an equation out of it to better make our lives easier. The same is going to happen with money. All right, so here we go. Please take a look at today's lesson. Go back to the first page. I'm going to read for you while I pull out the document. Most people saving for the future. Oh, it did not post. Okay. Most people saving for the future do not have a lump sum just sitting around. Do you remember our examples in class where we were saving for retirement? And anyone remember how much money did we need right now at the age of 17 if you wanted to be a millionaire? Anyone remember from last class? No? I forget what it was. It was pretty decent. It was like 5 digits. It was like 30 something thousand, I think. Welcome. But do you have 30 something thousand? Even that amount might not be an easy amount to have when you are in high school, right? When you're still a teenager. So take a look. If I could share this screen right here. Okay. It is more realistic to save a little bit over a long period of time. For example, if you want to go on vacation, it might save some money, you might save some money every month over a couple of years, and then see how that grows, right? That idea is called an annuity. You're constantly putting money in. And here is the analogy. The analogy is this. Let's pretend you have yourself tiny snowballs. And you're rolling, okay? Let's pretend that's day 0 or month 0 or year 0. In year 1, because you were rolling it, in other words, you were making interest, the snowball got bigger. So far, so good? But at the end of the year, because you made some money, you put money into it as well. So what do you expect? That snowball got bigger. So now it's big. But at the end of the year, now that you have some money, you're putting a little bit more in there. So not only is the snowball gaining more snow because you're rolling it, you're adding more snow onto it. So not only is it getting bigger in one way, you're getting bigger in another. You're getting bigger in 2 different ways. So by the time you get to year number 3, it became significantly bigger. And then at that point, again, you made money, so you put money in there. And so not only did it pick up snow because you were rolling it, you are picking up more snow because you're adding into it, right? And so what I want to show you is this idea. It starts off slow, but at a certain point, it will, boom, take off. Does that curve look familiar? What kind of function is that? Starts with an E, and we did it in chapter 7. Yes? Thank you. Thank you. Okay, it's an idea. Remember we talked about, like the zombie question where all of a sudden the zombies go boom, right up, right? We talked about what else? Bacteria. I think in my test or something, I talked about Mr. Kim, getting food poisoning, right? I ate salmonella, the bacteria boom goes up. Anytime it boom goes up, we're talking about an exponential, and that is why we have an exponential equation. But the question is, how do we make that work for us? So this is my analogy. I'm going to change this analogy on you. But for now, anytime you see a question where we are adding into the pot, I don't care if it's your savings. I don't care if this is debt. I don't care whether we are losing money or gaining. If you are adding money into the pot, it is going to be a regular annuity future value question. Let's take a look at an example. Okay. Imagine Mr. Kim wants to go on a trip to Europe in exactly 4 years. He decides to deposit $100 each month into an account earning 3.6% compounded monthly. Let's represent Mr. Kim's payments using a time diagram. A couple of things I am going to do for you as a heads up. I know my capital R is going to be $100. And I didn't talk about what capital R is. It's a repeating payments. Capital R is repeating. My R is going to be 3.6%. And my N is 12. Can someone quickly do 0.036 divided by 12 for me? Really quick on the calculator. Someone have it? Some of you might be able to do it mentally. Yep, 0.003. You can't see it's already here. 0.003. Okay, here it is. I am putting in money at the end of every month. Let's do this. Okay, this is going to be my months. Okay, that's month 0, month 1, month 2, month 3. And of course, how many months at the end of 2 years? That's 24. 24, which means this must be 23, which must mean this is 22, which must mean this is 21 months. So far, so good. How much money did I put in at the first month? What does the question say? What's my recurring payment? 100. And then, 100. And then, Sage, 100. Fill this in and pretend you put in $100 every month. Here's where it might get a little messy. So if you have a ruler, by all means, use it. I am putting in $100 every month, right? All right, I'm going to work backwards. Trick question. Okay, don't think too hard about it. If I put in $100 in the 24th month, how much interest did I earn on this $100? Exactly. No time has passed. Let's take a look. Everyone look at the 0.003. That's how much interest you earn every month because you did it right here. Right? You did R divided by N, and that is 0.003. You ready? How much interest did I earn on the $100 I put in last month? How much time passed? For this $100, how much time has passed when I got to 2 years? Yep, 1 month. 1 month of interest. You know what percentage that is? 0.036. That's for the entire year. So how much did I earn in 1 month? 0.003. That's yep. Remember, 0.036. That's per year. /A, per annum. And that, because it's per annum, but it's compounded monthly, we have to divide by 12.
Okay, yeah.
Right? And so this, if I use the exponential function, do you remember this one? A is equal to P equals 1 plus R over N over NT. You remember that formula? I'm going to use that here. My $100 earned for 1 month. How much did that second one earn then? I'm going to actually solve this. Okay, I'm going to put a little equal sign, so leave a space there. How many months passed for this $100? 2. So the exponent is a 2. So someone will do that. How many months passed for that $100? 3. So all the way to this one. How many months passed? Be careful. How many months? 20, 23. So I'm going to do this very quickly. This, I'm going to do my calculator. 100 times 1.003 gives me $100.30. This $100 earned me 30 cents, right? The next $100 earned me 160 cents. It earned me 60 cents. Whoa! The third month, the one that gained interest for 3 months, earned me still 90 cents, not 91, just 90, okay? But the very first $100 that I put in, if you do the math, that thing grew to $107.13. Does that make sense? What are we doing here? What are we trying to do? What we are trying to do is figure out how much all of this will add up to. What is the total amount of my investment if I were to start an exponential growth every single month, starting with $100? And so my question to you is, do you want to calculate every single one of those individually? No. I'm going to show you then, this is essentially what happens. You are taking your $100 and you are going to add with this, and then you are going to add with this. You don't have to write this down, I'm just trying to show you. And then you're trying to add with this. Do you see how there is a pattern going on? Because it's a pattern, we can use that field of math I talked to you about at the beginning of the class, and we end up with a formula. It makes our lives so easy. And I'll show you in the next page. Ready? Write an expression to show the future value of each of Mr. Kim's deposits above. Here it is. Calculate the total amount. So I'll ask you again. I need to find the total amount of all these red boxes. Do you want to add them manually? No. Let's use the equation. Okay. I'm going to do B and C in the next page. So leave this drawing as is. Go on to the next page. I am going to use the formula for us for the first time, but you have to memorize some of these numbers for my question, okay? Anyone still copying? A little bit? Okay. So work with that while I give everyone else a bit of a pointer. I need everyone to identify what is A, what is R, what is little r, what is little n, and what is little t for this scenario. Read the question. Once again, Mr. Kim is going on a trip. It's growing at an inch. I put money down $100 every month. It's growing at 3.6% a year, but compounded monthly. What are all of these values? I'll do the first one. There is no A. That's what we're trying to figure out. We want the final value. What is capital R? Good. What's little r? Continue.
That's not 3.6.
It is 3.6. That is per year. And what is my compounding period? How often am I doing this a year? Yes. Good. Compounded monthly, so 12. And how many years? Good. Let's plug in. Everyone, I need you to practice with your calculator. I'm going to plug in the equation, and you're going to be pretty surprised by how powerful this formula is. Yes? Pardon? Yes, go ahead. So this is capital R, and that is in a larger bracket. with 1 plus 0.036 divided by 12, all to the power of 12 times 2, which is 24, minus the 1, close that big bracket. All of this is divided by r over n. And if it helps, put this in a bracket. At this point in time, I guarantee at least one person will make a calculator mistake. If you don't want to make a calculator mistake, I highly recommend you solve this first, or rather solve this bracket first, followed by the exponent and the subtraction of 1, and then divide by the other thing.
Why did you put 22 as
22? No, it's 12 times 2. No, it's okay. It's understandable. So that would be 24. If you are the type to do each calculator portion separately and then write it down on your piece of paper, I recommend you keep as many decimals as possible because we're dealing with money here. Okay? You only round the money when we get to it to 2 decimal places, but up till then, don't round. Let's see if I could do this. 0.036 divided by 12 plus a 1, that's the power of 24, minus 1 divided by 0.036 divided by 12 minus 1. That's it. I'm going to give you a good minute or two. I need everyone to try this because every year there's always people who are, who are underestimating bed mass, who are not doing it properly. So I'm going to pause this video. Everyone take out your calculator, see if you can do that. Okay, please be careful of the carelessness. So part C of the question, I'm going to read it for you. It says, calculate the final value of, calculate the total amount of money Mr. Kim invested and then calculate the final value of Mr. Kim's investment after 4 years. I'm going to actually change it up on you just to give you an idea of what you might be expected to do in your assignment. How much money did I put in? I'll go back. How much money per month? 100. How many months? It's 2 years. So how many months? Not 12. That's for 1 year. For 2 years is 24. So how much money did I actually put in? 2,400. How much am I getting out? 2484. So my actual interest would be 2484.65 minus 2400. The interest that I earned over 2 years is $84.65, which doesn't seem like a lot. It's true, but you only invested for 2 years and you were investing $100 at a time. So it's not easy to grow money in this way, but the longer you take, the longer your first snowball gets to snowball. Let's take a look at some other more interesting examples, okay? I think this is going to be good for you. Here we go. Example 1, we'll do it again. Exact same question. Lily will deposit $1,000 into an account at the end of every 6 months for 10 years. The question is, do you think you can save up, if you had a regular job, do you think you could save up $1,000 every 6 months? Maybe, maybe not. How much will she have at the time of the last payment if interest is 5.5% per annum compounded semi-annually? Let's fill this in. What's my final amount? I don't know. What's my recurring payment? Yes, that's That's how much is repeated. What's my interest rate? Good. And then continue, Karen. 2, 10 years. I'm just going to plug it in. If you understand that this is a recurring payment, right? It happens again and again and again. You know that is annuity. It's going to be that big, big formula. And so we'll use it. 1,000 square brackets. 1 plus 0.055 divided by 2. All of that to the power of 2 times 10, so that's 20, minus a 1 for reasons that I can't tell you right now, 0.055 divided by 2. And again comes your calculator skill. Let's see how many people can repeat their success from the previous question. I'm going to give you that answer. I'm going to wait for a brave volunteer. If you're feeling pretty good after doing the first example, or if you want to test your mettle and see if you can do it. Good. Or 300. It could be me. 26 I got. Let's see. 0.055 divided by 2 plus 1. That's all to the power of 20 minus the 1 and multiplying by 1,000 and divided by the same interest rate. I got 26,197 and 40 rounded. 397, so 40 cents. Anyone got any? You got the same thing as me? It could be me doing it wrong. Let's try it one more time and see if Keely is right too. I could be wrong. Let's see you work through the calculator. Yes. Oh, okay. So that discrepancy is probably because I didn't round it. That's okay. That's the same. That makes sense. Yeah. So yeah, even small, like even leaving out all the decimals here, right, actually makes a big difference when it comes to money. So do your absolute best to not round at all. Well, that's good. 26,000 or in the 200 range. Correct. So the question again, I'm going to go back. Everyone, I did this for 200 months. $1,000. So this is for fun. Okay, this is for fun. You don't have to copy this down. I put in $1,000 for how many opportunities? I did this for 10 years and twice a year. So how many times did I put in money? 10 years, twice every year. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 20 times. So how much money did I actually put in? 20,000. But over 10 years, it grew to 26,000. It's not a bad deal, especially if you're doing this for the long term. If you're looking for like immediate money, it's probably better to go get a job. But if you are putting in a little bit every time. It will grow exponentially. Take a look at this. This is something I recommend everyone do. In fact, let me read this first. James deposits $250 into a mutual fund at the end of every month for 40 years until his retirement age. If the fund has a record of earning back 6.5% per annum, compounded monthly, determine the value of the fund when James celebrates his retirement. This is something that I'm doing as well. You might as well call James Mr. Kim. At a certain age, I started putting in $50 a week, so almost $250 a month, into an investment fund. It's been a handful of years now. It's grown quite big. It's now in the 5 digits, but it's $50 a week on a teacher's salary. It's something that I can do. And if you had a part-time job, let's say you work 10 hours a week at Shoppers Drug Mart or something, would you be able to afford saving $50 a week? Would you miss it? Maybe. Some of you are like, well, I need every single dollar I can get because my family's in trouble, or I have to pay for some kind of medical bill, or I need to afford all of my, my cell phone, my internet, all of that stuff. I have to pay for all that. Like, I don't know what your situation might be, but if you are able to afford $50 a week, in other words, $250 a month, for let's say 40 years, at the age of 25, take a look at what that turns into. Ready? I don't know what my final amount is, but my recurring payment is $250. And the stock market, getting back 6.5% is pretty modest on average in the stock market, okay? Assuming there's no recession like we have right now. Well, I won't say it's a recession, but it looks pretty dismal. Okay? The compounding period is 12 times a year, and I'm doing this for 40 years. So I'm gonna actually multiply this for you right now. This is 480. So you can put that into your formula. Your final value, your future value is 250. Multiply with 1 plus 0.065 divided by 12. Close bracket. 480 minus 1. Hoping by now that you see a repetition in this formula. Everything, hey, welcome. I got some stuff to hand back to you after, so don't leave without getting this from me. Okay, good. Good. You plug that into the calculator. Someone tell me what their final is. .065 divided by 10 power 480. It's something big. Don't be surprised and don't be shocked. Assuming I do this until I retire, I expect myself to have something about this much in my bank account. What'd you get, man? No, not yet. Okay. Yep. 57,000. $50 a week. $50 a week. So my question to you is, doesn't have to be 50. How much are you not going to miss every month? If I told you, let's say I was some terrible person and I bullied you and I'm like, yo, you better pay me every month. How much money are you willing to give me without missing that money? $10? 20? How much will you not miss? Let's remember, you're on a paycheck or you're on a salary or you're making business on Etsy. I don't know. How much will you not miss a month? I told myself that I wouldn't miss 200 bucks a month or 250 a month. Okay. All for the sake of putting it somewhere. And yeah, I'm telling you right now, 6.5% is modest over 40 years, right? And if you want to talk about average, the S&P 500, in other words, the stock market, has given back on average 10% a year since 1950. So forget 6.5. Someone want to change this formula and turn it into 0.1? Right? What do you get? What if this was actually just 0.1? In other words, 10%. Tell me what my money should grow into if that was the case. Try it. So again, this is all for the sake of you trying this formula again and again and again. Don't be surprised either when you see this number. It's something stupid. How much money would I expect if this was actually the case? It's going to be a stupid amount. Somebody? Starts with the 1. Has anyone got it? No? If my calculations are correct, I will finish with $1.5 million. Not because I'm rich, but because I'm letting the math, I'm letting the exponents do the work for me. It's snowballing. All I'm doing is putting a little bit of money every month. But the snowballing, the amount of snow that the ball picks up as it rolls over time is doing that. It's ridiculous. Think about it like this. For 40 years, for 480 times, I am putting in $250. I am putting in $120,000. And of course, math doesn't predict real life perfectly, but it models it pretty closely. So assuming that there is no market crash, we don't go into a depression, that the world doesn't have wars all over the place and people are dying left, right, and center, because that's what's happening over there, right? Assuming everything is normal, my $120,000 becomes over $1 million. Hence the advice, you don't get rich on salary. Hence the advice, start early. Hence the advice, don't take out money emotionally from the stock market. Hence Warren Buffett saying, get greedy when people are fearful and get fearful when people are greedy. All that stuff goes into trying to get exponential functions to work for you. Let your interest, let your money make money for you. That's all math. That's all it is. Your goal, my homework for you, is anytime I give you a question, number one, let me write this down. This is how I'll finish my video, okay? Write this down. Number one, identify if the question is a future value annuity, as in, are you putting money, are you adding money to make the snowball bigger? Okay, you have to read the question if you want to figure that out. There's no other way. There's no hint. You have to choose between one formula that I gave you today or the other formula that I'll give you on Thursday. Okay, figure out whether it's future value annuity, and then figure out what your A, R, little r, and T is, and then plug in and solve. Careful of calculator mistakes. Okay, that's all it is. And I hope you see the potential. It's like there is actual hope for all of us if we're talking about finances. And the earlier you start, anyone is familiar with that internet movement called FIRE? No? Financially independent, retire early. It's something that picked up on the internet when I was in my 20s. And I think a lot of people started learning about it and so on and so forth. And they're really working hard to work and make money now so that they can enjoy the rest of their life and not like enjoy it when they're in their 70s. You know what I mean? And so they're like, why are you busting your butt and working hard when you're basically gonna pass away in the next like 10, 20 years? I want to enjoy it while I still have energy in my bones, right? So it's that idea. And so a lot of people are tapping into this, whether you learned it in school or not. They're starting to understand the savviness of money, letting the math work for them, and they're starting early, right? Mr. Brown in the math department, he started when he was in his teens. So he's in his 40s now, and we talked a lot about money back when we were doing basketball together. You know, like he's doing well for himself. I'm not saying he's rich or poor, but he knew about this when he was younger. I did not know about this because my math teacher never actually talked about money. He was more worried about me knowing my functions so that I could be ready for university, right? Not that I hate on my math teacher. I love the guy to death. Like he was so cool. But for you and my parents never taught me about this either because they were fearful of the stock market. They were immigrants. They came when I was 5 years old. Based on someone's advice, they put a lot of money into the stock market. And guess what? 1999, like 3-4 years after we came, or 1995, I forget, there was a big stock market crash. Not only that, the housing market plummeted. So all the stuff that they put their money in thinking it was going to be okay, it all almost went to zero. So throughout my entire life, they're like, don't get into the stock market. We have bad experiences. It could be really dangerous for you. Yes and no, right? There's always a risk to everything. And it's unfortunate that my parents felt the brunt of it so early in their investing career. But no one gets rich off of a salary. That's a fact. Okay. So again, I'll stop the video here. Your goal for today's lesson is going to be getting familiar with how to do these questions. Why not just start with number 3 and see if you can answer each of these? Read the question carefully. And even if you know it's only one formula, read it anyways. Because on Thursday, I give you your second formula, right? So practice reading the question and noticing what kind of questions I can ask you. All of this is textbook questions. And of course, we have the answer key at the end. Tomorrow, I'm gonna take that same equation, I'm gonna get you to do some algebra with it, which I know you don't like, but it's absolutely necessary for our assignment. So please practice today. And that's it. Any questions? Any questions about like money and getting rich and finances? Mr. Brown and I love to talk about that stuff in class, so. No? Okay.